Alright, so here's a factoring technique called the difference of squares. Alright, the difference of two perfect squares. Alright, it comes from this little formula right here. If you have some number plus b times that same thing, but where one's plus, one's minus, it will always multiply out like this. Alright, it'll be the first number times itself minus the second number times itself. Alright. B times B, A times A. Right. So we're going to use that to factor stuff like this. When you have some number times itself minus some number times itself. Right. This really is just a special case of factoring. You could think of it as, two numbers that multiply to give us 36 and add up to give us 0, if you wanted to think of it that way. But it's not really that crazy of a formula, so we'll just remember it. All right. So we're going to have, something like this. What this formula says, to find out what the factored form is, you just take the square root of both of these. All right. Well, the square root of x squared is x on both of them, and the square root of 36 is 6 on both of them. Okay. And then one's plus, one's minus. The order doesn't really matter. So that's it. Okay. The next one, x squared minus 64. Same sort of setup. Square root of x squared gives us x. And one's plus, one's minus. Doesn't matter. Square root of 64 is 8. Okay. I do want to point out real fast, this does not apply. You cannot use this little trick if it were x squared plus 64. All right. It has to be a minus sign right here in order to use this formula. So if it's the sum of two squares, there's no way to factor it. All right, you can't do it. And last one here. So we're looking for some number times itself that will give us 4x squared. So what number or what thing times itself gives us 4x squared? That would be a 2x and 2x. And then what number times itself gives you 9? Well, that is 3 and 3. All right. In the next video, I'll have some more of these. Will just be more complex looking examples. All right.